and today we are going to be talking about projectiles. In the last class, we were able to treat some problems, okay, on how to solve problems on addition of two or more vectors. The resultant of two or more vectors, and we were able to get to a point where we were able to find the direction. Okay, like someone DM'd me. I would prefer you write your question in the comment section, please. Okay, so I'll start by answering the DM. Okay, the direction is for resultant of two or more vectors. The direction is usually tan theta is equal to EFY all over EFX. Simply put, we can say Y over X. That's the direction. Is that okay? So today we are going to be looking at projectile. Projectile. What is a projectile? A projectile is simply any object thrown into space and is able to travel along a curved path or a parabolic path. Now, in projectile motions, it is characterized into two. One, horizontal motion. It is characterized into horizontal motion. That is to say, the projectile is moving with constant velocity. If the velocity is constant, it means that the acceleration is equal to 0. Okay, no wonder the definition of acceleration is the rate of change of velocity with time. So if there's no change in velocity, it means that acceleration is equal to 0. 2. Vertical motion. Now, vertical motion, in this case, the acceleration due to gravity is equal to 9.8 meter per second. G is taken to be 9.8 meter per second square. Okay? In this case, the motion could be either upward or downward. So let's check out the diagram for a projectile. So if we have this as our sketch, so a body moving in a curved path. Okay? Let's say this is the Y and this is the X. This is the horizontal motion and this is the vertical motion. Okay? Now, of course, if you check this diagram, it means that the body will move with a velocity. Here, when it gets to this point, which is termed the maximum height, the body begins to fall. Okay, so here is called the maximum height. Okay, the maximum height is the time it takes the body to reach. It is the highest vertical distance reached. The highest vertical distance reached. Okay, of course, it is being taken. The height is being taken from the horizontal plane. This is the horizontal plane. Okay, so far this is the highest. So maximum height is defined as what? The highest vertical distance reached. Okay, now this is what we call the range. This is what we call the range. The range is simply the motion of the body from the point of projection to the point where it hits the projection plane again. Okay, the horizontal plane again. So That horizontal distance is called the range. Okay, now the time of flight is the time it took this projectile to move from the point of projection to the point where it hits the projection plane again. Now, that is taken as capital letter T. Now, the time it takes the body to reach maximum height, the time it took the particle from this point to reach the maximum height is not taken as time of flight. It is taken as time to reach the maximum height. Now, that is denoted with small letter t. Okay, small letter t is the time to reach the maximum height. Looking at the diagram, you will see this is the maximum height. This point is like half of the entire motion. So, from here to here is small t. The time it took the particle to move from this point to what? The maximum height is called what? The time to reach the maximum height. Why the time of flight is the time it took the particle from this point to the point where it hits the horizontal plane again. Is that okay? Now, when we are looking at after projection rather, the projectile is motion is taken in this form. When it is upward, there are two velocities involved, okay? But the resultant velocity is v, okay? So we have this as a vy, and then we have this one as a vx, okay? Now let's suppose this is for upward motion. Let's suppose this is what? For the upward motion. Now for the downward motion, we have something like this. Sorry, not this. Downward. It's going to be something like this. Okay, remember the angle is going to be with the horizontal, okay? We have this. The angle is going to be with the horizontal. So this is our Vx. And this is our Vy. And then this is our resultant V. Now, this is for the downward motion. This is for the downward motion. So either ways, if you have your diagram in this way or a problem in this way, either ways, we use Pythagoras theorem to solve. Now, what is our Pythagoras theorem? To find the resultant, V is equal to Vx squared plus, V squared is equal to Vx squared Vy squared. So V is equal to what? The square root of what? Vx squared plus what? Vy squared. Okay. How about the direction? You want to find the direction of this problem. It's simply tan theta is equal to Vy squared all over Vx squared. Theta will then be equal to tan inverse. Tan inverse. Tan inverse will be our theta. Okay, before we solve a problem, let's quickly state the formula for time to reach maximum height is denoted with T, and simply equal to U sine theta all over G. Then time of flight capital letter T is simply T is equal to 2U sine theta over G. Then we have maximum height. That is the highest vertical distance. Capital letter H is simply U squared sine square theta all over 2G. Then the next one is range. Range, which is the horizontal distance. The horizontal distance is denoted with capital letter R. Is what? R is equal to U square sine 2 theta all over G. This is the formula for time to reach the maximum height. This is the formula for time of flight. This is the formula for what? Maximum height. And this is the formula for what? Range. We will solve a practical problem that will undo each of these formulas.